Okay, let's unpack this. If you're operating at scale today, I mean, startup or global enterprise, doesn't matter, you have to deal with containers.
Right.
And if you deal with containers, well, you inevitably hit the complexity, managing hundreds, maybe thousands of them,
Mm-hmm.
which brings us straight to today's topic, Kubernetes, or K8s, as you often hear it called.
Hates, yeah.
We're doing a deep dive into this infrastructure layer, the thing that really makes modern distributed systems, well,
Be
possible.
fundamental now.
Yeah. And our goal isn't just, defining K8s. We want to get into why it's become the standard, like everywhere.
Yeah.
And specifically break down those components, the things that actually deliver the promises,
Yeah.
velocity, scaling, efficiency.
And let's just say it up front, based on everything we looked at, Kubernetes is, it's validated. It's the gold standard.
Right.
This isn't some experimental tech anymore. It really provides that reliable, necessary foundation for building and deploying systems that need to scale, need to be available 24/7.
Okay.
It's basically the backbone for a lot of the modern web.
That makes sense.
Yeah.
But let's assume, our listener gets containers, they're the neat packages of code, dependencies, all that. Why do we need this extra thing? An orchestrator? Why not just, run the containers on VMs?
Well, the problem isn't running one container. It's managing the chaos when you have thousands.
Ah, okay.
K8s is essentially, think of it like a resource management layer. Sits on top of your hardware. It handles the scheduling, the self-healing if something breaks, the scaling up and down, networking.
All the messy stuff.
All the messy stuff, automated. And that radically simplifies deploying your apps, and crucially, it optimizes how your machines are used. You're not wasting expensive CPU cycles, not wasting RAM.
And that resource bit, that's where the rubber meets the road financially, right?
Definitely.
If my machines are running hotter, closer to full capacity, I'm spending less on my cloud subscription. It's a pretty clear incentive.
Exactly. And, beyond just the direct cost savings on the cloud bill, there's a structural benefit too. K8s abstracts the data center even further.
What do you mean abstracts it?
Well, the underlying complexity of the hardware, is it physical? Is it virtual? Is it cloud VMs that's hidden from the developers building the apps? And that simplification, it just ripples through the whole organization, makes architecture planning easier, makes day-to-day operations much smoother.
Okay, here's something fascinating the research highlighted about standardization and maybe the politics of infrastructure.
Yep.
K8 gets called the universal orchestrator because you can run it anywhere.
Mm-hmm.
So let's say I'm already deep into Amazon Web Services. They've got their own orchestration, right, like CloudFormation.
Yeah, too.
Why would I take on the extra setup complexity of Kubernetes then?
That's the critical strategic point. CloudFormation, it locks you right into AWS squarely.
Vendor lock-in.
Totally. If you ever think maybe we need to move some workloads in-house or maybe try Google Cloud or Azure, you have to completely retool everything. Kubernetes gives you that flexibility advantage. It's portable.
So if I learn the Kubernetes command line, the kubectl thing,
Yeah, kubectl.
that knowledge just works everywhere.
Precisely. The commands you learn, the patterns you design for your applications, the monitoring tools you hook up, they work the same. Identically.
Yep.
Whether you deploy to Amazon's cloud or your own servers in the basement or another cloud provider, the orchestration logic doesn't change.
And a huge piece of that portability, which the consensus really hammers home, is that K8 is open source.
Crucial point.
How does that help in practice? Beyond just saying no vendor lock-in.
Well, it translates into speed and trust.
Yeah.
Open source means you've got this massive community contributing.
Right. More eyes on it?
More eyes, faster bug fixes, constant security patches, way broader tooling support because anyone can build for it. You're not stuck waiting for one company's roadmap. So enterprise developers can adopt this really powerful universal tool, and they know they aren't painting themselves into an architectural corner, which is, frankly, a massive financial hedge against getting stuck with proprietary systems.
Okay, let's shift gears a bit. Let's talk about the specific, tangible results. What does this platform actually deliver? We found these sort of 4 pillars of Kubernetes benefits. Let's go past the generic definitions and see how K8 pulls them off. First one, velocity.
Right, velocity. It's often just thought of as being fast, but with K8s, it's more about safe speed.
Safe speed.
Yeah, the ability to ship lots of new features, lots of updates really quickly while making sure the application stays up and running, available. K8s achieves this because it has built-in support for things like immutable infrastructure and rolling updates.
Can you unpack rolling updates a bit more? What does that actually look like?
Absolutely. So when you deploy a new version of your app, K8s doesn't just, rip out the old one and slam the new one in.
Okay.
It automatically and gradually replaces the old running instances with the new ones, one by one or in batches, and it monitors health checks the whole time. If the new version starts throwing errors, it rolls back automatically.
Ah, okay. That's safety net.
Exactly. That process drastically cuts down the risk of deployments. It makes developers confident enough to maybe ship 10 times a day instead of, once a month with fingers crossed. That's real competitive velocity.
Okay, pillar number 2, scaling.
Yeah.
Everyone talks about scaling, but K8s is noted for scaling consistently. How does its design make sure it's stable when, say, traffic just explodes?
Yeah, it comes back to that decoupled architecture we touched on earlier.
Right.
The core design principle in K8s separates the things actually running the application code, those are called pods, from the stable network entry point, which is called a service.
Wait, hang on. Decoupling the address from the actual application unit, why is that so key for scaling?
Because the application instances, the pods, they're ephemeral. They're designed to come and go constantly.
Okay.
K8 scales them up or down automatically, moves them between machines if needed. They don't have fixed identities in that sense. So imagine you're running a huge e-commerce site. It's Black Friday. Traffic spikes massively. K8s can instantly spin up hundreds of new pods to handle the load, the service. That stays the same. It's the single, unchanging network address. It uses its built-in load balancing to spread that sudden rush of traffic evenly across all those new healthy pods.
So it just handles it elastically?
Elastically, reliably, consistently, no manual fiddling required during the panic.
That flows right into the third pillar.
Yeah.
Abstract. We talked about portability, but let's dig into the developer separation idea. You said developers are sort of purposefully kept away from the physical machines.
Yeah, that's a good way to put it. It means the developer just defines what their application needs. I need this much RAM, this much CPU, I need this type of storage attached.
Okay, like a wish list.
Sort of, yeah. A requirements list. And then K8s does the messy job of figuring out the best place to actually run that workload within the whole cluster of machines. Developers interact with the abstraction, the K8s API, not the bare metal or specific VMs.
And connecting this back again, this abstraction, this hiding of the complexity, that's what drives the cost reduction we talked about.
Precisely. Because K8s has this global view of all the available resources, CPU, RAM, across all the machines, it can pack workloads onto the cluster way more efficiently than humans could ever do manually.
Right. Better Tetris playing?
Exactly. Better Tetris. So if you're using your hardware, say, 80% of the time instead of maybe 30%, you just need fewer machines overall. You're cutting down your capital expenses for RAM and CPU purely through smarter software management.
Okay, last pillar. Benefit number 4, efficiency.
Yeah.
And this one's focused specifically on the dev environment.
Yeah, this really targets the developer's day-to-day workflow. Think about setting up a test environment for a big, complex application.
Ugh, painful.
Historically, yeah. It meant getting dedicated VMs provisioned, configuring them. It was slow, it was expensive. With K8s, developers can spin up isolated testing environments really quickly, really cheaply, using small, dedicated Kubernetes clusters, or even just namespaces within a shared cluster.
So like temporary sandboxes.
Exactly. Sandboxes that perfectly mimic production. They can be created on demand, torn down when finished, maybe even shared between team members. It drastically cuts the setup cost and speeds up that inner loop.
Yeah.
Code, test, debug, repeat.
All right. We've covered the why, the big benefits. Now let's get into the nuts and bolts a bit. The architecture that makes the abstraction and scaling actually work. We need to talk about how things communicate, how access is controlled, specifically those key components, services, ingress, and namespaces.
Right. This is where you see how K8s connects all the dots internally. Those benefits we just discussed, especially scaling and abstraction, they wouldn't be possible without this structured internal architecture.
Let's start with Kubernetes services. You called them the stable dress book earlier.
Yeah, that's a good analogy. Services are the critical abstraction for networking inside the cluster. They do 3 main things. First, discovery location. Like you said, pod IPs change all the time. They're ephemeral. The service gives you a stable DNS name that doesn't change. Second, they act as the internal load balancer, specifically layer 4 load balancing, distributing traffic across all the healthy pods that match that service definition.
Got it.
And third, they provide that stable naming for microservices. So internal components always know how to find each other reliably. It's like the unchanging phone number for a department, even if the people in it move desks.
Okay, so services handle traffic inside the cluster,
Yeah.
between the different microservices.
Mm-hmm.
But how does the outside world, the actual user typing a URL in their browser,
Mm-hmm.
How do they get routed to the right place inside?
For that, you need ingress.
Ingress. Okay.
If the service is the internal traffic cop, ingress is kind of like the bouncer at the main entrance of the club.
Okay.
Ingress objects provide that necessary external entry point. The API surface area for the whole cluster exposed to the internet. And crucially, they operate at layer 7, the HTTP/HTTPS layer. This lets you define much smarter routing rules based on the URL path or the subdomain requested, things like that.
So if I have, say, api.mysite.com users and also api.mysite.com orders, the ingress figures out that users goes to one internal service and orders goes to a completely different one.
Exactly right. It's that smart reverse proxy functionality. It lets you consolidate potentially many different applications or microservices behind a single external IP address. It often handles things like SSL termination too, and that complex path-based or host-based routing. It connects the wider internet to your internal service discovery.
Makes sense. Okay, final component, namespaces. This sounds less about traffic flow and more about organization, control.
That's a perfect description. Namespaces are purely about organization and setting security boundaries within a single Kubernetes cluster.
Right.
They provide isolation. They give you total access control for every microservice grouped within them. Their specific job is to control the degree to which services can see or interact with other components in the cluster.
Can you give an example of that control? How would you use that?
Sure. Let's say you're running a multi-tenant setup within one cluster. Maybe you have a development team's environment, a staging environment, and your live production environment all running on the same physical machines.
Okay.
You'd put each of those environments into its own separate namespace. Dev in one, staging in another, prod in a third. This ensures that services running in the dev namespace, for example, cannot accidentally talk to or mess with the configurations, the resources, or the running services inside the production namespace.
So it's like walls between teams or environments.
Exactly. Necessary walls for governance, for security, for preventing accidents. Segregation.
Okay, let's wrap this up then, bringing it all back together.
Yeah.
We've seen Kubernetes as this kind of universal translator, right? It simplifies enormous operational complexity. It abstracts away the hardware completely, standardizing how you operate. And it delivers these huge benefits, deployment speed, reliability, and ultimately lower cost because you're using your resources so much better.
Yeah.
It really feels like the infrastructure lingua franca for modern distributed systems.
It's the mechanism, really, that lets you take a bunch of commodity hardware, just servers, and make them act like one coherent, highly efficient distributed computer.
And given everything we've talked about, the validation, the widespread adoption, I mean, companies actively choosing K8s, even with its initial learning curve, choosing it over simpler proprietary tools like CloudFormation, that raises a really critical, practical question for anyone building systems today, wouldn't you say?
It absolutely does. If you're designing a system now, you have to think about its long-term viability. And Kubernetes has clearly shown the market strongly prefers open standards and portability. So the question you have to ask yourself is, if I commit today to a proprietary orchestration tool from a single vendor, how much risk am I taking on? What's the potential financial cost, the technical headache of having to re-platform in 3 years or 5 years when that vendor decides to change direction or jack up the prices? Kubernetes suggests that maybe, just maybe, prioritizing universal open source architecture from the start is the smartest financial and operational hedge against that kind of future uncertainty. Definitely something for you to consider as you make your next big architecture decisions.